Hello, everyone. Welcome to our virtual event on synthetic data generation. We're going to give everyone a few more seconds to join the call. There are a lot of people registered for this event. Seems to be a lot of interest in the market in synthetic data, and we're going to dive into it in a few moments. I just want to mention already now, if you have any questions throughout the presentation, you're more than welcome to ask us any questions. There is a question button on the top right of the screen. There's a question mark button. Click on that button, and you'll be able to submit to us questions that may arise throughout the course of the presentation. So here we go. My name is Amitai Richman. Welcome. I'm Director of Product Marketing at K2View. Joining me here is Yuval Perlov, Chief Technology Officer at K2View. Hi. And we are going to talk about unlocking the power of synthetic data, techniques, use cases, and pitfalls. So first of all, we're going to talk about the market, the synthetic data market, the various industries that are adopting synthetic data, who are at the forefront of adoption. We'll talk about top use cases for synthetic data and different generation techniques. We'll also talk about the benefits of generating synthetic data, as well as the pitfalls to watch out for when embarking on such an adventure. We'll talk about the pros and cons of the different generation techniques. And we'll also talk about the K2View synthetic data management, how we see the life cycle of synthetic data, our own platform for generating synthetic data, and more. At the end, we'll finish off with recommendations, practical recommendations on how you can implement synthetic data generation in your company and in your organization, followed by a Q&A session. Just a few words about K2View. K2View is a data product platform powering operational and analytical use cases for the enterprise. Our focus primarily lies in serving key sectors such as financial services, healthcare, telecom, retail, government, and other industries, offering tailored solutions such as our test data management suite, which includes data masking and synthetic data generation. Last year, we made a very exciting debut in Gartner's Magic Quadrant for data integration. We highly recommend you check out what our customers are saying about our product on Gartner Peer Insights. So Yuval, before we get into things, let's first talk about why we're even talking about synthetic data. Why would anyone spend lots of time, effort, and resources to generate synthetic data when one can just use real data?
Right. So thanks, Mitai. That is, of course, the reason we're gathered here today. So you use synthetic data when your real data just doesn't exist. The system that would generate it is not deployed yet, or it's inaccessible. Some regulation or architecture inhibits you from accessing this data. It could be insufficient, so there is data but not enough variance of it, or not enough, not big enough data sets. It's imbalanced. It tends to be one way and not the other, or it has a limited coverage. So in all these cases, you would want to use synthetic data. It could be for testing, for machine learning, for we'll go deeper into that. But it's in all those cases where your existing data is just not good enough, or doesn't, or cannot be used for regulatory reasons. And this is where synthetic data comes in. It's artificially generated, can be random, can be statistically, mimic some statistical properties, can be structured or unstructured data, or semi-structured. And the idea is that in order for it to be high quality synthetic data, it has to follow real data very closely. So it has to be with the same statistical properties, with the same with the same interconnections between data that tends to have certain relations to other data has to stay with those relations. So creating a synthetic data set is a rather complex activity.
Okay, great. So let's talk about the market. The synthetic data generation market is very small right now, only around $300 million this year, but it's projected to grow to 2.1 billion in 5 years. So it's a very young market with dozens of pure play vendors, as well as legacy vendors that have gone into the synthetic data generation area. So Gartner is tracking around 60 vendors, and they estimate that all of us together have less than 1,000 customers. They say it's an emerging technology with a low degree of enterprise adoption. They see all the venture capital funding pouring into this industry, and they see it as a bullish indicator of the robust future of this technology. They believe that the number of providers will multiply and that the customer base will quadruple in 3 years. Here's a quote from them. They say by next year, 60% of the data used for the development of AI and analytics projects will be synthetically generated, which is incredible. And Forrester is also very bullish. They say that synthetic data can help to reduce the cost of data acquisition by up to 80%. So the analysts are very much excited about synthetic data. And you can see this also, not just the analysts, you can see this in Gartner's hype cycle for data science and machine learning. This year's hype cycle came out very recently. And you can see that, no surprise, generative AI is at the top of the hype cycle. Now, if you're like me and if you've gone on LinkedIn anytime over the last 6 months, you've seen AI, AI, AI. Everybody's talking about AI. Every company's talking about AI. And it's very much at the top of the hype cycle. Also, synthetic data is fairly up high on the hype cycle, and as we said before, this is very much a very tracked, very interesting use case. So
and maybe
yeah.
Let's add to that that it's a very exciting time for this market because there's so much innovation in this early stage of using synthetic data and generating it. One reason is the regulation pressures, CCPA and other privacy regulations. And the second is the emergence of generative AI, which opens a lot of opportunities. So there's tons of innovations in this market, and it's a really exciting time to be part of it.
Yeah, absolutely. Thank you, Yuval. And Gartner says that we've only penetrated 1 to 5% of the target audience. That synthetic data is only, so that means that more than 95% of companies that will ultimately adopt synthetic data have not yet adopted synthetic data. So it's a very early market, and vendors are very often at the proof of concept stage, and only a handful of vendors can show referenceable customer implementations. And you see the quote here on the screen that Gartner feels, based on their research, that there's a lot of skepticism about synthetic data because people intuitively know that they trust data. We're all data oriented and data driven. And then when you talk about synthetic data or fake data, then it can almost be a negative thing. And so that's really what we want to talk about now. Is fake data positive or negative? If you ask me, when I think of something fake, I think of, let's say, a fake Rolex watch, right? You can go into the market and buy a fake Rolex watch for, a few dollars or whatever it is. And to me, it connotes something that's inferior. So is synthetic data something inferior, or is it actually better than real data, better than the real thing? So I think the answer is complex and nuanced, and I'll be happy to hear from you, Yuval, as we go through the presentation, your take on the positive and negative aspects of synthetic data. But first, let's talk about, yeah, Yuval, you want to say something?
Yeah, I would say that it definitely depends on the use cases, and we'll definitely dive into that.
Yeah. So not everyone is yet on board what I call the fake data train. There's some industries that are more advanced. For example, the financial services industry and the healthcare industry have a very defined use for synthetic data, and hence their adoption of it is further along. To give an example of a financial services use case of synthetic data, so imagine a financial services company wants to build a fraud detection model to detect fraud amongst customers. So the company is processing vast amounts of data every single day, lots of transactions, and they're looking for fraudulent transactions. So let's say they found a transaction here, a transaction there. It's not massive amounts of data. In order to train an ML model, which I'll be happy for you to explain soon, Yuval, but in order to train the model to detect fraudulent activities, you need lots of fraudulent transactions. So synthetic data can be used to simulate these fraudulent transactions. In terms of healthcare, Yuval, can you share with us, please, an example of what kind of situation within the healthcare industries a company would want to use synthetic data?
Yeah, sure. So healthcare is one of those areas where regulation dictates a very strong privacy restrictions on the ways software vendors can use data, and as well as organizations. And any system you would like to have in your organization, or any software system you would like to test, has to deal with HIPAA compliance and the privacy of patient data. So the way around that is for a lot of your testing and a lot of your modeling, a lot of your data sharing, to use synthetic data rather than real data, which is very prohibitive.
Got it, thanks. So let me share an example about the retail industry. For the retail industry, synthetic data can be used to train and test autonomous checkout systems, cashierless stores, before deploying them in the real world. And in the government and defense sector, synthetic data can be used to train ML and AI models to recognize and respond to new threats that are very rare in the real world. Hopefully will never happen, but their models need data of cataclysmic events that could happen or other security threats, and synthetic data can be generated to go into their models and build a threat assessment and threat mitigation. So it's time for our first poll, and this is the time to hear from you guys. If you click on the top right corner of your screen, there's a little graph there. Click on that, please, to see the first poll. And we want to ask you, how far along is your company in terms of adopting synthetic data? So go take a look there. It ranges from, we're exploring synthetic data but haven't decided to use it yet. We've decided to use synthetic data and are actively exploring its implementation. We use synthetic data in specific projects but not company-wide. Or we've really embraced synthetic data fully. We've got synthetic data throughout our organization. And we're big believers in synthetic data. So you can vote now, please, on the poll. The poll is completely anonymous, so nobody can see who it is that is voting. And we'll see the votes as they come in. We'll all see the votes in real time being tabulated. I'll give you half a minute or so to vote, please. Okay, so far, we see a majority of people are exploring synthetic data, but haven't decided to use it yet. So that's kind of intuitive with what, coming on to a session like this to learn more about synthetic data. You're doing research, exploring the different possibilities, different use cases, probably want to do some internal talks. We see 22% so far have decided to use synthetic data and are actively exploring how to do it, how to implement it. That's great. And see 25% of you are already using synthetic data for specific projects, but not using it company-wide. So that's great. I see the numbers are still, people are still voting. But I think the trend is pretty clear that there are plenty of people interested, and yet a lot of people have already decided to use synthetic data or have implemented it to some extent. So let's move on now to the top use cases of synthetic data. So just to list them off briefly, and then we'll go into it into more detail. The first use case is software testing. So to use synthetic data to assist in software testing. The second use case is to generate synthetic data from machine learning models. A third use case is to share data either across organizations or internally in big organizations while taking care of compliance. And the fourth top use case, there are more than four, but here are the top four, are training and simulations. Here at K2View, we see the most interest from the market in the first two, in using synthetic data for software testing or for machine learning models. So let's dive into those first two cases. So for software testing. So this is something where we have a lot of experience here in K2View in the area of test data management. So dev and QA teams need high quality test data to test software applications. Traditionally, data engineering and IT teams provision data to lower environments. And we help these teams by helping them provision compliant data and empowering testers to provision that data on their own. So the ability to provision robust, high-quality, compliant test data on demand increases the test coverage and enables testers to create diverse data sets covering a wide range of scenarios. And this way, dev and testing teams don't have to wait for test data because they get test data anytime that they want. They can generate it on their own. So Yuval, question for you, please. Why would organizations need, in this context, synthetic data for software testing if they can just use production data? Yuval, I think you're on mute. Can you double check that you're not on mute?
Yes, I am on mute. Thank you for pointing that out. I've been talking for some time now. Thank you.
Sorry.
So,
yeah,
software testing. You can use production data, but it has to be masked. So at a minimum, you have to transform the data, and it's already partially synthetic because all PII data, all personal identifying information has to be masked, replaced with some random values, ideally with completely random values that have nothing to do with the original data. And there's a challenge there because it has to be consistent, right? Data has to have relational integrity or data consistency. If you mask some data to some value in the same context, you have to do that in a repeatable manner. More than that, it's still limited. Maybe you want to test cases where data does not exist in production. It's a new version coming in. Or maybe you just want to take a data set, but transform it in a way that would augment the test cases. For instance, data aging. You want to age the data set in a certain way. And I already see we have questions about data aging. You want to age the data in a certain way. And kind of try and predict how it would look aged. And it can be as simple as, let's just change the dates and see what happens when for instance, a license plate expires, if that's your use case, or try to predict how the data set would behave given more time. And the transformations you would have to do on the production data are as complex as the testing scenarios you want to test. And at some point, your data set would become completely synthetic, with no relations to the original, whichever technique you're using, whether it's machine learning or randomly generated data using rules, et cetera, et cetera.
Thank you, Yuval. Before we move on, I just want to address the questions that are coming in. A few of you have submitted questions, and thank you for the feedback and the comments that are coming in. I want to remind everyone that if you have any questions throughout this session, please click on the question mark on the top right of the corner, and we'll address as many questions as time allows at the end of the session. I think, Yuval, let's talk about the second use case, about machine learning. Could you please explain to us about machine learning and synthetic data generation?
So machine learning, in order to train them, they are extremely hungry for data. And getting real life data is hard, right? There's it could be expensive. It often has to be tagged to make to be useful for machine learning algorithms. These tagging procedures are sometimes extremely laborious and time consuming, and there's so much data you can get from the real world. And there is a paradox here. One of the questions I see here touches on that. I mean, if you use machine learning to generate synthetic data, and then you use that data to train a machine learning model, what value does it have? And it turns out there is a lot of value, because different machine learning techniques have different limitations and different strengths. They certainly can augment each other. And there is a thought experience we can do. Take a student that's trying to learn simple calculus. So they solve a few of the exercises they get from the teacher, but they want to learn more, right? They want to get better at it. It turns out they can make up additional exercises to solve, and solving those additional exercises can improve their ability to solve equations. And the reason is they use different methods to create new questions, and they're different from the methods they use to create the answers. So they can definitely augment each other. And of course, that can break. If you create the same exercise again and again, or not enough variations in the complexity of the exercises, of course, then you're wasting time and maybe even reinforcing bad behavior. But if you use a good synthesis model, you can definitely improve your learning capacity. So that works well.
Great, thank you, Yuval. So let's take a moment to summarize the benefits or potential benefits of using synthetic data. So first of all, and I think this is the most intuitive, when you're using synthetic data, it implies that you're not using PII, PHI, you're not using sensitive data. And of course, vast majority of enterprises need to comply with various privacy standards such as CCPA, CPRA, GDPR, location-based, or it could be industry-based, HIPAA if it's healthcare, etc. So if you're using synthetic data if you're able to use synthetic data instead of real data, that handles the security and privacy concern. Now, secondly, and similarly, in terms of data sharing, if you can replace part or all of the data with synthetic data, then you can share data sets internally, externally, and you don't have to worry about a lack of compliance. Also, in terms of data diversity, sometimes the real data doesn't have the diversity that you want to include for whatever reason. And this may be due to sample selection, or you want to test edge cases in software application testing, or perhaps the demographic, the diversity is not what you want it to be. So with synthetic data, you can make the changes that you want to the end data set. And sometimes obtaining real data for analysis or training purposes can be challenging due to the data scarcity problem. As Yuval mentioned earlier, machine learning requires massive amounts and diverse data sets, and the real data is often incomplete. But it's very, very critical. Now, what's interesting is that smaller companies and smaller enterprises may be at a disadvantage in terms of their ability to secure real data, in terms of the real data that is accessible to them. But with synthetic data, they can level the playing field and develop products and services with synthetic data. So now we're up to our second poll question. This is our last poll. Please, as we did before, go up to the poll section on the top right and answer the following question. What is your or your company's primary use case for synthetic data generation? And you can see the options are software testing, data privacy and compliance, machine learning model training, data sharing, whether it's internal or external, or for creating prototypes, demos, simulations, or some other use case that's not listed there. Please take a moment to vote, and we'll see how the results come in. By the way, one of the use cases that we didn't mention, for example, in the fourth option of creating product demos, imagine that, for example, you want to onboard a new vendor for some kind of use case, could be data integration, data migration, any kind of project like that. And you want to test the vendor software, but you don't or cannot use your own data for privacy reasons that we mentioned before. Creating a synthetically generated data set that you could feed into the vendor's software could actually address that problem of testing vendor software. So that would be in part 4. And so far, what we're seeing in the poll results is very, very clear that the majority of the people who voted are saying that their primary use case is for software testing, and they want the data to be privacy compliant. So thanks for voting, everyone. And we're going to move on. So Yuval, can you please share with us the different approaches and techniques to synthetic data generation?
Right. So we briefly touched on the main ones as we discussed them, but let's make it formal. So the first one, and maybe most prevalent, is taking real data and moving it around and transforming it in order to mask it and kind of touch on more use cases as needed. But you start with a kernel of truth and then change what you have to change in order to meet your needs. And if you take that to the extreme, we can call that even rule-based data manufacturing, because the more randomly generated yet consistent points of data you use, you kind of shift from real data all the way to rule-based, where with rule-based data manufacturing, your entire data set is randomly generated while keeping data consistency. Another method that's applied is data cloning. So if I can take a real live scenario, but I just want more of it in order to test, to load test, or to test some UI element to make sure it works well with a lot of data, what I can do there is repeat the same data set again and again, but each time apply new data masking to it. So I can get the same data set again and again while changing the parts that are masked, and create multiple copies with some differences between them to the same data set. Statistical modeling, of course, is been with us for a long time, and now generative AI is the hot new topic. New libraries such as GPT and also older techniques before that, make it possible to take a real life scenario, but instead of using the data directly, use that data to train a generative AI model in order to generate more of that data, more of that data, but data that tries new data, completely synthetic, that tries to keep the relations and the behavior of the fields inside the original data set. And the nice thing with that is that you don't have to tell it, the relations. It will capture it from the original data set. So those are the, I would say, prevalent approaches.
Okay, thanks, Yuval.
Yeah, sure.
But before we continue, I want to ask you about what I presented before, and the benefits of synthetic data. I listed out lots of benefits about compliance and data scarcity, overcoming various challenges. I almost described it as a magical solution that can solve any complex data problem in the enterprise. Did I get carried away, or can you keep me honest?
Right. So definitely something to keep in mind. Synthetic data is not real world data, right? It could be potentially inaccurate, especially if you use techniques that are inappropriate. You get drift, right? If you don't get a good enough sample of real world data, you start drifting from the original intent of the data and start to create synthetic data that's not accurate enough. So you need enough data to train on. What is called GPT hallucinations, right? If you don't have the problem with the generative data is that it always has an answer. The question is if the answer is good enough.
Right.
Time-sensitive information is not always easy to deal with, and of course, the more complex your data relations are, the more trouble you're going to get into maintaining those relations. And once you're at a certain number, current techniques find it really hard to follow. Of course, part of the problem is that synthetic data requires time, right? You have to validate that the data set is correct. It's resource intensive and or time consuming. So you're either throwing a lot of resources at the problem using machine learning techniques, or it's time consuming where you have to create the rules and make sure that your automatic data discovery worked well and discovered all the connections. So all of these are pitfalls to take into account when you're starting a synthetic data project. So with K2View, we started our test data journey with data masking and transformation. So our basic framework, what it does really well is to move business entities around. So instead of moving tables around, we model business entities up front. We know what a customer is, what a household is, how a store looks like, how a credit card looks like, how a patient looks like, etc., etc. We model all of that up front, and we know how to move it between systems. So the basic problem of extracting data and then provisioning it to another system, that's solved right there in our framework. We've added to that data masking and transformation, and really what we've got is a best of class data movement approach to test data management provisioning, and that has been with us for some time. And of course, data cloning is just repeating that process again and again. So that was very straightforward thing for us to do. Just copy the same provision the same customer again and again. Just run the masking the masking phase again and again. We've added a lot of discovery capabilities to that in order to facilitate creating and managing this provisioning and extraction of entities. Then we went all the way and said, okay, if we have all these data manufacturing techniques and we know how to keep relational integrity, let's also give the option of going from a completely, starting from a completely synthetic data set and just apply all these data generation techniques on the without any kernel of real data. Just use transformation on the entire data set, just without transforming anything. Everything is randomized, and we know how to set the right randomization technique to the right field type. So that's our rule-based approach. And what we're adding now is generative AI to that. So we can use our data provisioning abilities to extract data from a certain environment, subset it, take the right subset of data, use that to train an AI model, and then use that model to generate more and more business entities, which we will then provision to your target environment. So that really gives one system that encompasses all these techniques.
So which technique, Yuval, would you use for which use case and which scenario?
Right. So it's a good question, and there is no way. Of course, it's whatever makes sense in your organization. But if we look, at a very high level, so rule-based systems are a bit labor-intensive, but you need them for that portion of the data where you don't have any existing data at all, or for non-functional testing or negative testing where you just need a lot of data and you need it without any reference data.
Can I just interrupt for a second, Yuval? Sorry. We had a question from the audience exactly about that. So how you can generate synthetic data without having access to original data. So part of the answer is, in fact, with this rule-based synthetic data generation technique. Sorry, yes. Please continue.
Yeah, so that is correct. And for ML model training, as we discussed, either masked real data or transformed data or AI-generated data can fit the bill really well. For data sharing and testing, masking is great. Generative AI can fit, of course, testing scenarios and even some data sharing scenarios. If I want to share across the organization how data tends to look like, but it's not the real data, it can serve me for use cases other than testing. Of course, for testing and analytics, especially if you do business analytics on your real organization, you need the real data, but you have to mask it. And then for load testing, both cloning and rules provide a very good approach to create massive amounts of data for load testing.
Okay, thanks, Yuval. So let me try to put it all together as it relates to K2View. So K2View prepares, generates, and provisions compliant, realistic, and accurate synthetic data by combining 4 different data generation methods that Yuval mentioned and the business entity approach. So let me drill down into that a little bit more. So in terms of the accuracy, we have a patented business entity approach which supports complex data hierarchies and relationships across multiple data sources. When generating data via machine learning, the end result data set is only as good as the training model data set. And one of our core competencies, as Yuval said before, is subsetting. So we're able to subset and prepare the data for the model exactly with the data that you need to optimize the end result. And as you know, some of the other synthetic data generation vendors, they choose one technique and that's what they go with. But what's special about K2View, one of the things that's unique about us, is that we're combining multiple different generation methods, and Yuval, I believe, is going to talk about that soon. So it's a very comprehensive approach that not only includes the 4 different generation methods, but also a robust toolbox that supports the entire data generation lifecycle, including the ability to extract data, to subset the data, to mask it, to synthesize it, to reserve the data for specific people, for example, to roll back to previous versions, and we can provision the data from any environment to any environment. So this is what we call the data lifecycle. It's not just generating data, but rather it's the entire data lifecycle, and not just the generation phase. So lastly, at K2View, we believe in agility, and we provide users with easy-to-use self-service tools to enable operators to be self-sufficient and therefore more agile.
Yes, and you definitely touch on those synergies. So, of course, it's always great to have one system with a lot of capabilities. But what we keep finding is that there's a lot of synergies between these methods. So first, of course, you only have to do discovery and metadata once, right? You need your business entity in order to extract the data, in order to provision it, in order to understand the relationships, in order to understand the data types. And every one of these techniques needs this information. So you only have to do that once. And then with different methods, there are different advantages and disadvantages for each method. And with the tooling, you can apply even to the same data set for different columns, different approaches. So you can take a data set that was AI generated and feel the limitations or compensate for the limitations of an AI model with some synthetic rules to do some post-processing after the fact. Or you can take production data, but then apply some more synthetic data to it. So the idea is that these techniques not only work in concert, but they compensate for each other's shortcomings. And of course, the ability to subset, like you said, is crucial for training. And we have some questions here around how do you train for edge cases? How do you train for a special population? And the fact that you can subset data before sending it to the training environment, that means you can choose the subset you're training on and then get more of that specific data set for your, get more of that data for your testing. Also, the fact that you can mask data before you train on that, employ masking, but then send that data to be trained on, that has two advantages. One, you get an extra layer of security that you're not sending PII to your training model, which can then spit it back at you if you don't have enough variance. That's one. That's if you have a very low number of cases to train on. And the second is training data is done much easier in the cloud. So getting the specific hardware needed for training is much easier on the big cloud providers. And maybe you need it for a short time, and then for other times you don't need it. So it makes a lot of sense to use resources, cloud resources for training purposes. The issue is that in many industries, there's a restriction for loading a data set to the cloud if it's unmasked. So by applying masking first, then sending the data to the cloud for training, you can overcome that. And of course, once all the data is ready, with whichever technique you created it, it all lives in one test data store, and then you can pick and choose which data you want to provision for your test data needs. I'm just going to touch very briefly on how it all comes together. So with our platform, there is what we call the data pipeline, where we prepare the data first, so we can extract, mask it, subset it, and now we have data ready to go. Then we can apply cloning rules or generative AI or just plain old randomly generated rules to create more of that data or transform the existing data. And then our platform allows you to operate on that data. So you can subset the resulting data set, provision it to other system, use that, reserve that data. So I can, if several testers are working on the same environment, they can reserve each one can reserve their own data, so they're not stepping on each other's toes. You can age the data, so you can take data that was generated by machine learning, but then age that in some way that fits your need, or you can use that data and then delete it from your provision environment. So you can roll it back and say, okay, let's roll it back to a specific point in time, whether it's delete it completely or just bring it to a certain point in time. So the idea is that all these operational tools that allow you to work with the data are available to you no matter which method you use to generate the data. They're all there for you to use.
Awesome. Thank you, Yuval. So this is our last slide before we get to questions and answers. So just before we dive into the recommendations, I just want to remind everyone, if you have any questions, so you can submit them. But please note that we've already received a lot of questions. Yuval, if you could start, please, reviewing those questions. I'm not sure if we'll have time for all of them. If we don't answer your question, then we'll get back to you after the session in the coming days to give you a specific answer to your question if we don't cover it live now. And also, please note that there is a copy of this presentation in the attachments. On the top right corner of the screen, you'll see a paperclip. If you click on that, you can download this presentation. So let's go into some recommendations on how to implement synthetic data generation for your organization. So first of all, you'll want to identify areas in your organization where data is missing, incomplete, or expensive to obtain. This is something that you've all talked about earlier on in the presentation. Sometimes, and we spoke about how sometimes real data is ideal, and if you have a straightforward use case for masking, that's great. But there are cases where synthetic data generation can really help. And now you don't necessarily need to create entire synthetic data sets. You can also do a hybrid approach where you merge real data with synthetic data in the same data set. So you can replace PII with synthetic data while keeping a lot of the real data intact. So that's something that you want to consider. And as in terms of if you're in the second poll, we saw that most of you said that your main use case is software application testing. So we know that there are various tests that you want to do, and the data might be difficult to obtain. It could be some edge cases that don't even exist in production. So synthetic data is an ideal answer to situations like that. So basically, the recommendation is to look for those situations and try to figure out what the right balance of real and synthetic data might be for your organization. And then we talked about earlier whether fake data is positive or negative. So there may still be some people who feel that fake data is negative, and so you'll want to educate internal stakeholders about the benefits and the limitations of synthetic data, as well as the business value that can be achieved from implementing a synthetic data generation solution. Furthermore, if you're evaluating multiple vendors, you want to conduct a POC to verify vendor claims and see, in fact, how it works. And keep an eye also on the entire life cycle in terms of how you source the data and what we talked about earlier. And choose vendors that can generate realistic synthetic data sets that really match your production data sets while managing the entire data lifecycle. And I'm going to end with a quote here from Gartner, which you can see, that the most common differentiators for tabular synthetic data generation platforms are the accuracy and privacy of the generated data. So keep in mind, take a look, make sure that any solution that you choose, the accuracy level is very high, and that they're keeping the sensitive data completely private. Of course, you're always welcome to contact K2View, and we'll be happy to demonstrate our platform at a later time. So we're up to Q&A. I've been able to see some of the questions. Yuval, I don't know how much you've had a chance to review them.
Yes, I went over them, and maybe we can group them into several buckets, not go one by one. So there's a lot of questions about how do we access source data and how do we provision data to target. whether it's a API or RDBMS based, what happens if the data is in the cloud. So I'll start by saying we started with a data movement platform, right? This is what our core, this is what the core of our platform does. It moves data around, of course, in entity-based form. That's our point. But the data can reside anywhere. It can reside behind an API. It can reside on a database. It can reside on a cloud service. It can be on premise. We can access data anywhere it is, and it's an open system. So if you have your own connector, bring it in. The system will be able to call it. If you have an old JDBC adapter for DB2 on a mainframe, we've worked with that before. If it's just flat files that are exported once a day, fine, we'll deal with that with an extremely open and flexible system. And the same goes for the provisioning part. Data can then be provisioned anywhere. And because we are dealing with data movement here, the source and the target do not necessarily have to be in the same format or the same structure. So we can apply transformation while we're moving the data. And that puts us apart. If you look at other approaches that are more about data virtualization approach, they hit these limits when you don't have access to the original data through an RDBMS, but you have through an API, or you have to do some data transformation and not maintain necessarily the same format or the same even data version. So think about taking data from version A, but having to provision it to your next version of the product where the structure of the tables has already changed. And now you have to deal with transformation because the data does not look exactly the same. So even those cases get a lot from data transformation, but again, extremely flexible, both on the extract and on the provisioning side. And that means that whatever technique you use, whether you extract the data to train or extract the data to transform it, it's the same extraction mechanism, right? You don't have to develop the extraction mechanism twice, and you get the same powerful mechanism for data extraction. And the same goes for provisioning, whether you've just transformed the data from one data set, or you're taking AI generated or rule-based generated data, or a combination of all of the above. You still get the same data provisioning pipeline available to you. So that's on that. I would add to that, there are some questions around here about how are we deployed? Are you a SaaS only solution or not? So we are. We started out the data fabric, the base framework that allows all of that started from an on-premise data solution. It's running in JVM, so you can just really run it anywhere, and it's also completely cloud native now. So you can. It's all been containerized and running against the cloud services. And the nice thing is that you can even take a hybrid approach where you're running it on your cloud infrastructure or as a SaaS offering from our cloud infrastructure. But some of our presence is on premise, and we can then extract data as close as possible to the source or provision it as close as possible to the target and move it around as compressed business entities. So there's extreme flexibility in the way we are deployed and the way we move data around. While I was talking, there are questions here around data drift, and I touched on that, so I'm not going to repeat it, but I try to answer those questions in the talk. How could synthetic data be useful to then train machine models, and does it always work? It does tend to work, but of course it does not always work, and we have to look closely at the case and see if synthetic data would bring enough value. Of course, as an industry, nobody really understands how AI machine learning algorithms work, but empirically, we do see that enforcing a machine learning cycle with synthetically generated data that's done in a high quality way does improve the overall machine learning cycle. There's another interesting thing here that came up again and again. how do you distinguish between real data and synthetic data, and can you watermark it? So, by the way, that is not something we thought of in the past, but this is one of those cases where bringing together synthetic data generation using AI, but then applying rules to that data could become really handy, because we can generate data using the synthetic data algorithm, and then apply some small transformation to it in order to watermark it. So the machine learning part does not have to deal with watermarking or creating some data that's not close enough to the real data. It can really focus on creating the synthetic data as close as possible to your real data set, and then we can apply some small transformation to it in order to watermark it and make sure the organization as a whole realizes you're dealing with synthetic data here. So that, I think that answers a lot of question here, a lot of questions around this
There was a question, Yuval, about different data types, structured and unstructured, semi-structured.
Oh yeah, I see that a lot. So yeah, that's the other point I wanted to touch on. So can we create data for image processing, or can we create data for testing that is completely unstructured, or what we call semi-structured, where there is a structure to the data, but there's no metadata explanation up front, right? There's no metadata repository that tells you this is exactly how the metadata is going to look. You just get JSON files or CSV files, and you have to deal with them on the fly. So the way we deal with that is for semi-structured data, we do have the option to learn metadata on the fly. So take examples and extract the metadata from them. And that becomes a really good way to then apply rules to it, or apply masking, or apply different data generation techniques. And that's part of our discovery engine. So it can discover semi-structured data. If there's huge variance in the data, so you can imagine a place where you have JSON files and each one of them has a completely different structures, we do have the ability to create on-the-fly rules that, using hints in the data, would then apply the right data manipulation technique or data generation technique to that specific field. Again, this of course makes the problem a bit harder, but we do have a strong tool set to deal with that as well. For completely unstructured data, there's no one answer, right? Because unstructured data can be anything. So what are the capabilities there? So we do have capabilities to take audio and visual data, analyze it, break it down to textual data, apply masking to it, and then rebuild it back again. That's one technique. Another technique is reducting parts of the audio or the video. I would say that here we have to really discuss what we're looking for and what we're looking for to achieve, because it's extremely nuanced, and every data set has its own problems to understand it, and its own goals in how you want to then generate synthetic data or mask the data on top of that. So that requires very close inspection, and to see how the tool set can meet the expectations there.
Thank you very much, Yuval. I'm afraid we're out of time. So as I said earlier, if we haven't answered your questions, we'll follow up with you directly. And if you have any other questions that you haven't submitted to us, so feel free to go to k2view.com, contact us, and submit your question to us, or ask us for a demo. We'll be more than happy to meet you and answer your questions. And you're more than welcome to follow us on LinkedIn to see our latest articles and information about this area and related areas. And we thank you for joining us today, and look forward to meeting you in the next webinars. Have a great day, everyone.
Thank you very
Thank you.
much.
Thank you and goodbye.